we normally do a status update on what's been happening with CTDB and what our plans are. And over the past couple of years, we've presented some great plans. It'll be interesting to see where we're up to, right? Okay, so what we're going to do, we're going to look at progress in the past year. In fact, yeah, so it is 2017 and 2018. This was wrong until this morning. We'll quickly go over what's happened with the plans that we've presented at the last couple of sambaXP conferences. We'll talk about some design ideas that we've had since then and talk about some new daemons that we think we're going to throw into this mix. And then we're going to wonder what the way forward is. Okay, in the last year, we've had a bunch of wonderful people contributing to CTDB. You know, there are some people who are just drive-by committers, people like Ralph Burma, just doesn't take this stuff seriously. Anyway, sorry. So it also kind of illustrates that there is really only one person working full-time on CTDB at the moment. Who would that be? Well, I spend a lot of time sleeping and cherry-picking patches and renaming them, putting my name on them out of Amitay's tree. That's how I do this. It's the only way I can. You get to a certain age. Okay, commits by area. Could have broken this down more, but there's just a few interesting areas to look at. There were a bunch of configuration changes done for Samba 4.9 in between sambaXP last time and the release of 4.9. And there were also a few bug fixes for that too, included in those commits. But it wasn't a lot. Most of the work had already been done. Amitay wrote a multi-component event-D to replace the one that we had in there. And, there's a bunch of commits there, plus a few little fixes. We did a whole bunch of portability work. The FreeBSD guys were shouting at us. There's an IBM guy who shouts at us occasionally. So we did that. As part of that, we looked at our packet handling because CTDB constructs some
raw TCP sockets, raw IP sockets and TCP sockets, TCP packets.
It constructs some ACKs, tickle ACKs, thank you, and ARP packets. And the code here was terrible. It had been copied, there was a system_Linux one, it had been copied to system_AIX, system_FreeBSD. Most of the code was copied and pasted between files, and in some cases the bugs had only been fixed in one place. So we just decided to go, no, let's merge that together. And that took a while, and that took a bit of testing. The wonderful improvements I made to the recovery lock about 3 or 4 years ago needed yet more fixing in the last 12 months. There's always fixes to this. It turned out to be quite racy. Amitay did some really cool vacuuming improvements, and there is more to come. There's some stuff sitting in a branch for 1.5 years now, and we really should get that out there because it does grossly simplify vacuuming. We just want to do some very careful testing. So vacuuming in CTDB is garbage collection. When we started using this new version of AutoCluster, it meant we stopped testing on RHEL 6 and started testing on something that uses this newfangled thing called systemd. And we were doing some pretty crazy stuff in our NFS self-healing code, and things broke badly. So there were, quite a few fixes needed there. The local daemon stuff I spoke about was a long stream of commits to clean up the test code so that stuff could be factored out. We've done a lot of work, 50 commits in the last year, just generically improving the test code. A bunch of people dived in and did WAF2 and Python 3 work. There's some stuff that was just generic Samba cleanups that, happened to CTDB too. And then there are your bugzilla fixes that don't fit into any of these categories, and just random fixes and improvements which account for, a quarter of all the stuff.
One thing to note here is that there hasn't been too much of new development in this last year, apart from adding a new event D. I mean, we already had one event D, so this was just sort of a rewrite to support multiple components. But apart from that, there hasn't really been any new activity. Just a point to remember.
So, are you going to comment on this stuff?
Yep.
Yeah, we haven't planned this at all. So, we do.
So we've been meaning to split CTDB as a monolithic daemon, which currently it is, into separate daemons. So we have made long plans on how to do it, what each daemon should do, and all those plans were presented in last 2 years, SambaXP. So this sort of gives you an idea of what the new CTDB should look like. So you would have an event daemon, a service daemon for just services, failover plus connection tracking for doing IP failover and things like that. Then cluster daemon. So every daemon is now very well defined and has very small action to do and whatnot. Of course, then there's the database daemon, which is really the crux of the whole CTDB. So we have sort of elaborated on some of them quite a lot. Some of them we have not even mentioned, things like transport, things like SMBD proxy. These are the things which might be required for integrating all the new stuff with the existing stuff. So what happened to all those plans? So Event D is now in Samba 4.9. Now this is the multi-component Event D which we needed, because now so Service D also could run events, Failover D could also run events. So we needed one Event D which can run all sorts of events for every other component. So that's already in. Service D, we finished writing the code way before 4.9 was released, but we never merged it. Then as 4.9 release came close, we were desperate to finish failover D and contract D. So we, in 3 nights or 3 days and one whole day session of hacking, we finished service D code. There's a lot of copy pasting, and but it's still required. It was standalone piece of code, not integrated, but was ready to go. Cluster D and database daemon, of course, we have not yet implemented. Transport, I'm still thinking about how to design it. So really, even though we have few components ready to go, they are not integrated. They're not, finally, they're not mature enough to go upstream yet. And we realize that as we are writing these various daemons, there is lots of boilerplate code we are just copy pasting, because every daemon has to set up, parse configuration, has to do socket IO and all that thing. So, and also now because we are separating each daemon, now we have to define protocol for each daemon separately. So then the question becomes, do we want to now distinguish between client-server protocol, where client is either could be a tool or could be SMBD talking to it, and server, whereas two database daemons talking to each other, whether they should have a different protocol or whatever. So there are also all these sort of ideas on how to design the new protocol. And so one thing to note here, that all these daemons were based on our abstraction called sock daemon, which basically took away a lot of common code of handling sockets and handling connections and setting up either single socket or multiple socket. So it was really good abstraction to give us a base for writing all these new daemons, but it didn't do enough. Also, we noticed from writing event D as a separate daemon that testing becomes very, very easy, because now you can fire up a single daemon and use the actual daemon, use the actual client tool to test against it. There's no need to fake either the client side or the server side, and don't have to do, write extra code. But then it also becomes complicated because now, if you want to test service D, now service D requires event D also to be running. So that means now to test service D, you have to have two daemons running. If you want to test failover D, it needs event D and transport. So now our test infrastructure becomes a little more complicated. So out of all this, progress which we did, we realized that we need to do some more changes, and we can't just push things as they are. So here are some of the design ideas that came out of this exercise. Obviously, we want to reduce boilerplate code as much as possible. Simplify testing, unify protocol, and how to handle too many sockets. Okay, so let's go one by one our various ideas and see what that leads to. So as I mentioned, SockDaemon was very good for abstracting the initial daemon, which has a single socket and does some I/O over the socket. Clients can connect to it and send some packets and things like that. Now, SockDaemon doesn't have any protocol handling per se, but it provides a callback mechanisms there you can deal with the protocol, but it's not very effective. And it's very limiting. So we now have a new abstraction called TDemon. So where it's now a bigger version of SockDaemon. So now it not only handles all the socket I/O, but now it also handles the transport. It also handles the protocol. So we are now trying to extract more and more common code and put it into a single abstraction. And obviously, once you have TDemon, you would also have a T client, which is now, again, because every daemon would have a client tool to talk to it, to query it. And then we don't want to, again, have the same repetitions in the client code. So we can abstract all the client code also as a T client abstraction. Now, as Martin mentioned, we have spent a lot of time improving our test infrastructure. So our focus on the new code is it should be really, really easy to test and to write test cases. So in the unit testing, current CTDB daemon is just impossible. You just cannot, there is no way, it just requires too much setup to do any sort of unit testing. And also, there is no way to test only chunks of code in CTDB daemon. Whereas separate daemons are much easier to test. Their functionality is well defined, and we can check all the kernel cases very easily. But as I mentioned, if we have separate daemons, now some of them require other dependencies. Like service D will now require event D to be running. So how do you handle these multiple dependencies? So service D could be just requires one dependency, but let's say database daemon or something might require 3 or 4 daemons other running at the same time for operation. So then the question becomes, is there a way we can combine these daemons? How do you combine these daemons? So now that's where we came with the idea that let's write each daemon as basically just a T-event rec computation, right? So one request starts up event D. One request starts service D. One request starts failover D. Now we can start all these services in one process, in one master daemon. Of course, now because now they are simple, separate T1 computations. So if we want, we can fork them and run as separate processes, or for testing purposes, we can run them in process, in single. So now for testing, if you want service D testing, all its dependencies gets bundled into one binary. Okay. Another idea was we don't want these multiple protocols for each separate daemon. We want to combine the protocol. Now, typically, you can identify any server code. You would have some way of sending some controls to change the behavior or change something in it, and there are many of them which are common controls. Like you want to set the debug level or get the debug level. Or for example, we might want to say support some sort of statistics. So we want statistics across various daemons. Now this is so common that we don't want to implement it again and again for each daemon separately. Now can we do that once? Also, as I mentioned, the client server code, so that is when the tool is talking to one of the daemons, and when daemons are talking to each other, whether they should have a separate protocol. One advantage of this is that then client cannot, call the protocol which is meant for server to server protocol. So it kind of offers isolation. But sometimes you might need the same control from client to server and between servers. So it's something which we haven't really thought about fully yet, but we have a clear idea on how to define the protocol. Of course, it's going to be a new protocol because the current protocol doesn't have all the elements that we need. And then, since we are doing it a new protocol, we want to make sure that it's NDN neutral. And it's not just structs on wire. So again, this fits in very well with the TDemon abstraction, which I mentioned earlier, because now we can implement all these ideas once and get protocol handling done right in one daemon. Now, TDemon is not really a daemon, it's just a framework. The other idea was also around sockets. So yeah, currently we have just one CTDB socket. Now, once you split up these daemons, you're going to have one socket per daemon, one Unix domain socket. It's easy to test when you're testing one daemon at a time, but it gets messy because now you have to manage multiple sockets in a test infrastructure and things like that. So how do you deal with that? So this is where I've been talking to Volker. So we wanted really a messaging server. Now, obviously, Samba does multiple processes and it already has its own messaging. Can we use the same messaging? So there is a idea of whether we can use the Unix datagram processing even in CTDB between various. Again, it's an ongoing discussion and decision making. So that's where the transport daemon comes in. See, earlier we had not decided on how all these daemons are going to talk to each other, or how one daemon on one node going to talk to same daemon on the other node. So now we have a more concrete definition of what transport daemon looks like. And also, because all daemons are based on TDemon abstraction, now we can use a common transport client code and gets embedded in TDemon abstraction. So that's just a bonus. Again, it fits very well. So we end up with some new daemons. So I have talked about master daemon and transport daemon. So let's look at a little more detail of what these daemons will look like. So obviously, master daemon can now start and monitor multiple daemons. In the master daemon, we want to make sure it's very light. It doesn't open any sockets. It doesn't do any I/O. It either forks processes and starts individual daemon in a separate process, or it could all start all the processes in single daemon. So this allows us to create various sort of sub-daemons for testing. So our service debundle with all dependencies, a failover debundle with all its dependencies, or even a complete daemon with all the dependencies. So all working components bundled in one. It's not quite systemd. Yeah, but this is much better. Yeah, potentially it can start Samba if if you provide a SMBD send and SMBD receive, we are all good. And next is the transport daemon. So every daemon basically is now talking to transport daemon. So within a node, transport becomes your sort of messaging construct, messaging daemon, and then it also handles packets between two different nodes. And we want to keep it as light as possible so that we can make it really, really fast. So we have some ideas on trying to make sure that we use as little dynamic memory, maybe buffer pools and all sorts of those things. So reduce to really make it fast, to reduce any memory allocations and things like that. So this is what has come out of all the exercises which you have done, all the code which you have implemented over last 2 years.
Just one hint, this messaging datagram that we talked about yesterday, that already at least attempts to completely do no allocations at all, at least in the fast path. So that might be a good infrastructure for that as well.
Yeah, definitely. That's why I added it in, because once I talked to you, I said, okay, that looks definitely good as a we might have to do something different for handling packets between nodes, but at least it solves the problem of how to efficiently deal with all daemons in the same node, all processes in the same node. So, how do we go forward?
We link arms and walk forward?
Yeah, sure.
Okay. You or me? I don't know. Let's go.
You can take.
Okay. So it's really nice to do incremental development so you're not dumping huge amounts of stuff on the list. So to make the best long-term progress, you want to avoid churn. And to avoid churn, we need to develop everything against the transport API, right? We've got this, we're going to have this transport API. All the daemons are going to talk to it, probably via the TDemon abstraction. So to complete this, we either need a new database daemon that's implemented against transport daemon API, or we need to retrofit the existing CTDB Decode against the transport daemon API. Both of those ideas, well, the latter involves so much churn, it's crazy. So one possibility would be to fake the transport daemon client, to have a fake transport daemon client and use CTDB as the transport, and that would actually allow things like failover daemon and service daemon to go upstream and be tunneled through CTDBD. We were talking about doing something similar, but this is a much more general idea. So then we can implement a new database daemon and transport daemon and then dump them in one chunk. That first step of implementing the fake transport daemon client to tunnel through CTDB, it involves churn, right? Because it's code we're just going to throw away later. Another thing is recovery scalability. Very occasionally we have some problems where we can't recover the databases because the cluster is very busy. And our recovery master node is probably the bottleneck here. We've got one node coordinating all the recovery, and every byte contained in every database has to come through that one node. So the recovery master node could actually distribute recovery of individual databases across the nodes and say, you recover this database, you recover this database, you recover this database. We could implement that in the current code, right? It's more churn. So what's my point here? We've got these grand ideas for a new design, but every time, and this isn't, I'm not saying this is unique to CTDB, lots of projects see this. Every time we churn, we delay progress towards our end goal. So, and doing incremental development here involves churn. So either we work as fast as possible and hopefully get to the end and dump this all in and have a brand new CTDB, or we spend some of our time doing incremental steps and we don't get there as fast. There's one full-time CTDB developer on the Samba team, so that person will admit to some amount of burnout if you ask them over a beer. They wouldn't admit it in a forum like this, though. That'd be weakness. So, if people love our vision and are feeling helpful and would like to listen to more details of this and take it on board, then, perhaps we can get there faster. So if anyone's bored, please help.
That's all we have. Any questions?
So with the code nicely and interfaces nicely separated, like you said, the master daemon just doing all functionalities for testing purposes. So what's the benefit or motivation for production to kind of have the multi-process model or forking multiple daemons? Is it mainly for scalability, not having one single event loop bottleneck?
Yes.
You said, like, for testing purposes, have the master D do everything in one process.
Correct.
But then usually assumption for production being it forks these other daemons as separately built processes. What's the advantage or what's the point for this?
No, so the idea was, obviously for testing purposes, we don't want to run 3 daemons or 4 daemons just to test one daemon. Okay, it just the test infrastructure code becomes more complicated because you need to set the dependencies.
Yeah, but why do you want? I mean, if it can all be done in one daemon with nicely separate code, like not for testing but for the other side, for production.
Yeah.
Why run it as multiple daemons?
Why run it as multiple daemons? Because we have seen that when on a busy system, CTDB is doing a lot. So currently, CTDB is single-threaded, is the bottleneck. So by splitting it up and by taking components which are not time-critical, like failover or service monitoring, they're not really time-critical. So by taking those components out, the core database daemon can become really, really fast.
And there's a couple of other things. If you, say, wanted to use something else for failover, say you were doing some multi-channel thing and didn't want to use CTDB's failover as part of that, you would configure failover enabled equals no, and the master daemon wouldn't. Well, failover daemon could then do nothing, or wouldn't end up forked. It could exit happily with a code saying, "I'm done here," or it could just sit there doing absolutely nothing. There are many options. And the other thing is, there may be some products out there that only use a subset of CTDB's functionality, and that means they don't need it all running.
Okay.
So one more point which I want to make. So I have only shown you the two ends of the spectrum. So one end, you run everything in one daemon. Other end, everything runs as a separate process. But there is somewhere in between also, right? Whereas we could run everything except database daemon as one process, and only database daemon is separate. So that's possible too. So, we have all combinations possible.
Sure. Okay, thanks. That's cool. One more question. In TDemon, what does T stand for? That's always what we ask when we create another T something.
T in Samba has always stood for trustworthy.
Thanks, that's great.
Okay, two quick questions. First is, why do you think that putting another transport daemon in between makes things better? Because we're adding another communication part and then some processing in between. And second question is, shouldn't we go and test the real thing? That means various daemons interacting with each other in test in order to catch all the problems, instead of setting up a simplified test rig that might actually miss issues we see later on when we scale that thing.
Okay. So now transport D actually falls out of this split design. You need some messaging. Okay. Once you split the daemons, you cannot have each daemon talking to its counterpart on other node. That's just stupid.
Well, you can.
No, it's not. Well, the problem is you can do it, but it basically means that every daemon has to have the capability to decide when the other node has died or whatever. So we want to keep that complication in one place. So we have already identified that once we have split all these daemons into separate daemons, we need messaging. So we need messaging for within one node between the different processes. And now it makes sense that this messaging entity or transport D does the job of also talking across the node, because then we can put all the logic for deciding when the node has died or when the node is not responding in one place, rather than trying to copy that code everywhere in all other daemons.
What was the second question?
That's the first one. And the second one is when we are testing individual daemons, see, it still requires other daemons to be present. It's not that we are testing service D in absence of event D. It doesn't make sense. Service D for its normal operation requires event D. So when we are testing service D, we are testing service D event D together. So they will be always tested in combination. But we are only testing the service D functionality. Now, when we are testing the full functionality, we are bundling everything in one daemon. So then we are testing the integration between database daemon, the main daemon, service monitoring, IP failover, database activity. So everything will get integrated, tested in integrated fashion. So it's not really separate testing.
Yeah. I mean, it really is unit testing. So if we do want to do testing on a real cluster, like we will still build packages and build all the daemons and run. So when we do our testing on auto cluster, we don't run in any fancy test mode. So similarly, later on, when we're running on auto cluster, we'll build packages and we'll just run the production CTDB to do integration testing. But, we can do some more limited testing
No,
in the all-in-one model.
the main problem with current setup is that we have to, if anything which we want to test, if it cannot be separated out, it has to be tested in an integrated environment. That means with a full cluster setup. With this, we can test the hell out of each component with all the corner cases and everything. And of course, we are not going to get rid of the integrated test, but that just to test the overall functionality. But all the individual functionality will get tested much better fashion with the new framework.
More testing rather than less.
Yeah.
So let me also put one answer to the first question. Of course, this separate hop between SMBD and CTDBD also worries me. And this is what I discussed yesterday with Amitay, that there is the number one operation in CTDB that is performance sensitive is get me a record. I mean, and for this, we, at least between SMBD and the database daemon, we will have to implement a direct shortcut. Whether for this operation, it needs to be seen whether the hop between the database daemon and the other database daemon, we have the other processes, whether that needs a special case that the database daemon also needs this logic to do extra TCP on its own. Might need to be seen, but there's a network hop involved anyway.
Yeah.
So, but we will have a direct channel between SMBD and database daemon.
Yeah, that's correct.
So all other things that I can imagine at this point are not that performance sensitive, that the extra hop across a transport daemon that then first has a complete picture of all the traffic, which is also good for diagnosing problems. And also, centralizes all that logic with node up and down and so on, is a good thing.
Yeah, and then the nice thing will be that the transport daemon will be really highly tuned. It'll only need to know enough of the protocol to shuffle packets.
That's basically just the header. So it can parse the header, know source and destination, and can route packets.
And if that turns out to be a problem, if that turns out to be a single-threaded single core problem, if that's simple enough, we could start multi-threading that, I guess.
Sure.
I mean, if that turns out to be a CPU bottleneck, because it's so simple, I would dare going multi-threading it.
Correct.
And we don't have all the other crap that then has to be thought about anymore because we've got rid of it.